All right, we have come to the live Q&A session for the keynote speech. Thanks, Ion, for a intriguing talk, and thanks everyone for tuning in. If you have any questions for Ion, you can enter them on the streaming page. In fact, I have already received some questions. So the first question is, it seems that there are two options for Ray to be leveraged for AI application development. The first option is to use a traditional ML platform empowered by Ray, and the second option is to use the Ray library directly. What are the pros and cons of each option?
Yeah, this is a great question. So obviously, like I mentioned, Ray has two components, Ray Core and ecosystem of library, which is built on top of it. And obviously, if the functionalities and the libraries which are built on top of Ray, you should use that because it's optimized for Ray. And it also works seamlessly, it's integrated seamlessly with the other libraries if you want to use more functionality outside the particular libraries you are considering. However, if you are like someone like Facebook or you are someone like OpenAI and you need to implement very sophisticated algorithms which are not present currently in the libraries, then you are going to be better off. And this is what some of these companies are doing, implementing new algorithms on top of the Ray core to train at a larger scales, to use maybe hardware which is not commonly available, and things like that. But the bottom line here is that Ray provides this through layers approach, provides you flexibility to basically implement virtually any distributed algorithm, not only machine learning algorithm, on top of Ray core, and for the most common functionality, for the most common algorithms, for the most common other libraries in the machine learning space, it offers easy to use libraries.
All right, thank you. And the second question is, you talk about how Ray will make it easier to develop AI applications and provide better performance and scalability to those applications. Does Ray provide any unique advantages in the deployment and management of AI applications?
Yeah, so I think, the main advantage, and the answer is yes. And the reason is that simply because, like I mentioned in the talk, with Ray, you can use a single system to scale different workloads, so you can implement your applications end-to-end. And why that is help with the management and deployment? Well, it's simply because it's easier to manage and deploy a single system than stitching together multiple systems like you had to do before to build this end-to-end application or machine learning platforms. And when you stitch together you need to stitch together different systems, like for instance, data processing and training and serving. There are many challenges because each of these systems come with its own way to deploy it and to manage it. But it's also, there are more subtle things. For instance, if you are looking like end-to-end fault tolerance properties or consistency properties, it's much harder to derive that from a bunch of systems you can chain together, each system with its own fault tolerance, semantics, and guarantees. Then having, again, a single system like Ray, which has very clear semantics of fault tolerance and data consistency.
All right, thank you. The next question is, are Ray actors similar or equivalent to DAPR actors or workflows?
Sorry, can you repeat that?
So the question is whether, I think you mentioned Ray actors, right? Right? Are they similar or equivalent to DAPR actors workflows? I'm not sure whether you're familiar with DAPR. It's a
Yeah. I'm not that familiar, unfortunately, with that. But I would say actually we do have, you mentioned about the workflows. Actually, it's a recent paper we have in NSDI, in OSDI, which was a few days ago, which we are having, we build a workflow on top of Ray and around the Ray actors. But it's like the way to think about Ray actors, it's basically your Python class you instantiate remotely, and then once you instantiate it, you execute methods. It's ready to accept methods, invocations on it. And the big deal about that as a functionality is the functionality is similar with that of many other actor systems. The nice thing here is that it's very seamlessly integrated in the Python with the Python ecosystem, and it's transparent. And the other thing, which is maybe the one different things from traditional actor systems, is that in traditional actor systems, typically like Erlang or even Akka and things like that, the arguments for the method invocations are sent together with the messages, right? The values for the arguments are sent via messages, and the results are returned via messages. And while in the case of Ray, the argument can be sent by reference. These are the futures to the data which is going to be consumed by the actor, which can be more efficient and than copying and sending everything together with the invocation or the arguments.
Sure, thank you. And the next question, you said that large models are much more accurate. How do you see smaller domain-specific models? Will they provide similar quality in the future, at least?
Yes, absolutely. I think that the smaller models, clearly we are going to see a proliferation of small models because for domain-specific applications, you can actually get excellent results by fine-tuning or doing prompt engineering using your own data. And we have, there are a couple of results we have at Berkeley, and in many other places, you see that more and more. You can take a model which is pretty small, even 7 billion parameters, of course, by today's standards. And if you can fine-tune for a domain-specific application, it can perform very well. In this particular case, it's, for instance, an application called Gorilla, which is, it's target the APIs. So if you have questions about how to do a particular things like listing the buckets in S3 or buckets in S3, then it's going to provide you the API, and you can use this API to execute and get your, the list of S3 buckets. And it's targeted for different APIs, PyTorch and TensorFlow and AWS and GCP and a few of these APIs. It's a little bit, but one level up from the functions you have recently in Open AI, offering. But with those one, you can actually, if you just again train these models on these APIs, the small models on the APIs, you can get better performance than using GPT-4. So it's a lot of promise there, and we are seeing this also. A lot of enterprises are obviously interested in using these smaller models, which are cheaper and are faster. And also they can be open source. These are open source models. So Facebook just released the Llama 2 today, and they are going to prefer that and fine tune on their own data or using their data to do prompt engineering to solve their domain specific problems. I think that's very promising.
All right. So that's all we have time for. Thanks again, Ion. And it has been a privilege and pleasure to have you. For our viewers, don't walk away, as the next session is coming right up, and it will be moderated by Aichu. Aichu, take it away.